Good afternoon, everyone. My name is Gloria Kahamba, and I'm from Tanzania. I graduated from secondary school there and received a Great Lakes of Africa scholarship to study here in 2008. And since when I was home, my interest has been in medicine and public health, and that was mostly because of the health situation in my country, which is still really poor, but also because I love studying and understanding human health. So when I came to College of the Atlantic, I took a lot of pre-medical courses and also health studies. And I've also tried to do internships which are related to that subject. So in 2010, I interned with the Ministry of Health and Social Welfare in Tanzania, and I worked in the epidemiology section, and I mostly assisted with collection of data and analysis of data. And that was a really great experience for me because it helped me explore a little bit about the field of public health. And afterwards, I was also hoping to do something about it later. So it's still part of my interest. But then I also wanted to have an experience in the medical field. So I did an internship with the Jackson Laboratory in 2011, which created a path into my senior project. So for my senior project, I worked with Dr. Rick Mazer, and we were investigating a cancer-related mechanism called ALT, or alternative lengthening of telomeres. And this mechanism has been discovered in about 10 to 15% of cancer. So it's still the research of it is still underdeveloped, although it affects very little, like the kinds of cancer, but it mostly affects bone cancers, brain tumors, and also some breast cancers. And its activity is mostly determined by investigating the presence of certain molecular characteristics in it. So for my project, we were interested in investigating the mechanism in a certain strain of mouse, which is the one shown by the arrow. So this mouse has a mutation. It lacks a gene which would allow it to have a normal lifespan, and it usually ages faster and it dies prematurely than the other mice. So as you can see here, it looks really smaller compared to a normal mouse. So, but recently, we found out that some of their cells started proliferating and they started living longer than they should. So we were thinking that they might be using another mechanism which allows them to do this because they shouldn't be able to. So we performed several experiments to test the characteristics of ALT, which are already known and have been investigated before. And we were using human ALT-positive cells to do this. So the human cells, we already knew that they should exhibit ALT mechanism. So when we did our experiments, we were hoping to find the mechanism in the human cells, but then we were using them as a comparison for the mouse cells that we were interested in. So the greater aim for this project was to see if these mice use ALT so that we can sort of like use them to study the mechanism so that we can understand how it works in humans, because you know it's not always easy to get human cells and all that. So this is just one of the properties of ALT that we tested, and the black, this was the result, and the black cycles show us the characteristic that we were testing is present. And as we can see in the human ALT-positive cells, we found the characteristics. So this showed us that they have the mechanism going on. But the mouse cells do not exhibit any of the cycles. So that could mean several things. And after, I'll explain that in a little bit. But after we tested several other characteristics of ALT, we were able to find them in the human cells, but not in the mouse cells. So what does this mean? So one of the conclusions could be that the mouse cells do not use ALT mechanism. However, we couldn't conclude that because there is a lot of different factors we have to test, and since ALT mechanism is still like under research, so like not much is known about it. So it could be that there are other characteristics that have not been discovered. So we think we know these few properties that we already have already been tested, but there might be other ones that haven't been tested, and we can't just say that the mouse don't use alt mechanism based on what we tested. So they could also be using another mechanism to do this or another gene. So it's really hard to conclude just from these few experiments that we have done, and we would need to do a lot more other experiments to have a real conclusion. And that is why scientists usually take a long time to make real discoveries. So, yeah. And, oops. Oh, sorry. Oh, so for that experience was also great for me, and I learned a lot from it. And I'd never done scientific research before, so it was just really nice to have that as part of my education at COA. So for my future, I'm hoping to take a year or two off and hopefully work in a health-related field or in a laboratory. And also afterwards, I'm hoping to go to graduate school and do a master's in public health or go to medical school. And I would like to thank you all very much. And yeah, any questions? So you're asking if the smaller mouse has a relation to our species? Oh, okay, so generally all the mice, their genome and their DNA is really close to humans. So it's not only like the smaller mouse, but that's why we are also using mice to, investigate all these mechanisms, because they are close to us, and because they are really small and they are easier than the other mammals. But the smaller mice is a mutant, so I mean, compared to the bigger mouse, probably the bigger mouse is closer to us, I guess. But the smaller mouse actually lacks a certain gene, as I said, which would allow it to grow normally. Does that answer your question? Okay. Oh, yeah. Koala, those will be so hard to keep, because the mouse, you can just keep them in a cage and, take care of, and they also, I guess reproduce easily and they take a shorter time, but I don't know, getting a koala bear and, keeping it at Jackson Laboratory, that would be kind of, so, yeah.